All right, continuing on, page 63. Acceleration. It is a vector measurement. Okay, don't forget, that means that it does have the component of direction in it. We'll get to that a little bit later. We define it as a change in velocity over time. Okay, that asterisk is there to indicate this, v delta, or something you may have heard, delta v. Those of you of the nerd persuasion who occasionally watch the NASA channel and watch a satellite get launched into space, you'll hear them talking about delta v. And recall from your 8th grade science, delta means change. All right. Now, we measure acceleration in feet per second, or meters per second, We abbreviate it as like so, feet per second squared, or meters per second squared. All right. Now, what do we mean by that? Well, the way to explain it, one way to explain it, is we'll use our old friend, the laboratory rock, once again. So, here on Earth, gravity is such that a free-falling object will accelerate at a rate of 32 feet per second per second. What does that mean? Well, it means that if I take the laboratory rock to a tall enough building or a tower and drop it, it will start with an initial velocity of 0 feet per second, but after 1 second of dropping, it will have accelerated up to 32 feet per second. And then after 2 seconds of free fall, it'll be up to 64 feet per second. And after 3 seconds, 96 feet per second, and so on. Usually at this point, somebody will ask me, what about terminal velocity? That has to do with a free-falling object moving through a fluid, whether it's a gas or a liquid. We could explain it this way. It's that point at which, given the thickness of the fluid and the geometry and weight of the free-falling object, where the speed of the object is matched by the resistance of the fluid, and it levels out and holds onto that one speed. So, for instance, a skydiver. We see skydivers jump out and they do that spread eagle type posture, perpendicular to their direction of free fall. And that comes out to roughly 125 miles per hour. That's generally terminal velocity for a human body. Unless you want to go faster, then you kind of go head first, and then you can go even faster. An urban legend that's been around for a long time is that if you went to the top of the Empire State Building and tossed out a penny, and somehow managed to get that penny to make it all the way down to the sidewalk, by the time it got there, it would be going fast enough to kill somebody. Well, that ain't quite so. Mythbusters did a beautiful episode on this one. It turns out that, again, given the weight and geometry of a penny and the thickness of our atmosphere, terminal velocity for a penny is somewhere around 60-65 miles per hour. That's it. It won't free fall any faster. So if you did manage to hit somebody on the top of the head with a penny from the top of the Empire State Building, you wouldn't kill them. It would sting like hell, but that would be it. Now, another common confusion point is this exponent that we see here. So I'm going to take a few minutes and wade through that one for you. So, like I said, here on Earth, gravity is 32 feet per second per second. So we would write that acceleration of gravity equals 32 feet per second per second. All right. That's a little bit confusing. So let's go back to what Galileo says to do with confusing things. He says, limit the scope of inquiry, or as I put it, the pizza principle. So we're going to pick this apart. We'll just talk about this part right here. 32 feet per second. Another way that I can write that is this way. 32 feet over 1 second. Because remember, I told you a few weeks ago, per means over here in Maine. All right, so there it is, 32 feet over 1 second. But we still have this hanging out there. So what we're saying here is this whole mess per second, which means this whole mess over 1 second. And that's still kind of messy. But let's rearrange this a little bit. We'll use a little algebra. Another way I can write this would be 32 feet over 1 second. That's this part here, divided by 1 second. Now, remember back in 5th grade when Mrs. Gilhooly was teaching you how to divide and multiply fractions. What do we do in a case like this? Well, we'll turn this into a fraction like so. Now what we're going to do is we're going to change this into multiplication, and we're going to flip this to the reciprocal. So now it reads 32 feet over 1 second. Change this to times. And the reciprocal of this is now it's 1 over 1 second, which equals 32 feet over 1 second times 1 second. Another way to say that, 1 second squared. So now we have 32 feet over 1 second squared, or how about this? 32 feet per second squared. That's where it comes from. All right, so hopefully this will clear up a little bit of confusion. We have been so conditioned to stop whenever we see that exponent and start squaring numbers, but in this case, no, we don't. It's just a shorthand way of saying per second per second. That's all it is, okay? Nothing more than that. All right. Next page.